Okay, so looking at another example here of tangent line approximations. By the way, another word that you might come across a lot is linear approximations. So obviously the tangent line is linear, so often this phrase gets used in general is linear approximations. Okay, so remember, this was the formula that we just came up with. It was y is equal to f of c plus f prime of c times x minus c. All this comes from is just finding the equation of the tangent line. You have our slope is the derivative, and this was our y value for the plugging in the x value of c. So let's see, how does this work now if we want to just approximate a random number, so the square root of 4.2, if we want to do this using linear approximation? Again, if you're trying to come up with something off the top of your head, you're like, maybe it's going to be a little bit more than 2, but that's probably as close as you're going to be able to get. How could you come up with a decent approximation for this that's just better than 2? Because obviously you know the square root of 4 is 2. So let's see, how could we use this? So if we want to use linear approximation, we have to come up with what is my f of x. So we have to come up with a function, f of x, to say what function are we really using here. And then we also want to find the c value. Remember, in our discussion last time, we said that the value of c, this should be close to where we're trying to approximate, right? The further and further away we get from our c value, the worse our approximation is. So we're going to try to come up with a creative c that might be close to 4.2. So in this case, our function that we're looking at is the square root of x, right? So this is our function. We're evaluating it at 4.2, but the c value, you're going to figure out what number is close to 4.2. That evaluating the function is going to be very easy because we need the function at a point. So obviously, we just mentioned earlier that the square root of 4 is very easy to calculate. So we can use c is equal to 4. And now we just need to find what is the derivative, what is at c, what is f of c, and then we know what c is. So if we know the derivative, well, remember, this, if you wanted to rewrite this, you could write this as x to the 1/2 power. Take the derivative by using the power rule. So you bring down the power of 1/2, and you subtract 1 from the power, and you have negative 1/2. Or you could see this as 1/2 times the square root of x. So this is my derivative. So if I'm looking for the derivative at c, I'm looking for f prime of 4. This is going to be 1/2 square root of 4. So this is just 1/4. Since the square root of 4 is 2. So I know that this is my f prime at 4. And then I also know, obviously, that f of 4 we said was equal to 2. So between these two things, I can now plug things into my linear approximation. So my linear approximation says y is going to be f of c, which we said was 2, plus f prime of 4, which we said is 1/4, times x minus our c value, which we said was 4. So now this is what our linear approximation is for any type of function. So y is equal to a 2 plus an x over 4 minus 1, or in other words, y is equal to 1 plus x divided by 4. Now, this is going to be true in general for our linear approximation, but we want to apply this specifically for the square root of 4.2. So this is going to be our x value. So we're going to plug in x is equal to 4.2. I plug this in, so now I see that the square root of 4.2, this is going to be approximately, I'm using this, 1 plus 4.2 divided by 4. And so now this is something that is a lot easier, right? It's a lot easier to do division, right? You could do some long division, see that 4 goes into 4 ones. This doesn't go in, but it goes in to 20. So we could get 1 is approximately 1 plus 1.05. So this gives us an approximation of 2.05. So linear approximation allows us to get better than just that basic approximation of 2 by using 4, and this says that this is going to be approximately 2.05. Now, obviously, you could plug into the calculator to see what a much more accurate approximation is, but again, without a calculator, this is an excellent way to get an approximation.